This is a pilot scale spray dryer. It's a small version of a typical spray dryer that we encounter in industry. It uses a centrifugal atomizer to generate droplets that will be turned into powders. And we use this dryer mainly to generate small sample when we want to test new formulation before we go into the larger scale dryer in industrial setting.
Welcome all to today's demonstration of Cody dryer. Cody dryer is generally a pilot scale dryer that is used for small scale production of different particulate powders. This dryer consists of 4 major parts. So one of the major parts starts with the heating section that heats up the air, and it just filters out the air and heats the air and then passes it to the drying chamber. Drying chamber consists of the atomizer. It is based on the centrifugal force, and this atomizer atomizes the droplets into fine mist, and this mist is converted to the powder form, which is then passed to the cyclone and then to the collector where we can collect the powder. This particular Cody dryer consists of different parts, and it starts with the process controller. It has a drying chamber. At the top of the drying chamber inside you can see an atomizer, which is the centrifugal atomizer. On the top of the dryer you can see the exhaust system. Connected to the exhaust system is the cyclone, which is later on connected to the collector where all the powder gets collected. In the hierarchy of the events, in the Cody dryer we first start with the peristatic pump. The peristatic pump is just used to introduce the feed to the dryer. In this, it is controlled by a control system that can control the feed rate of the feedstock that we are going to introduce to the atomizer, which is on the top of the dryer. The second important part of the Cody dryer, and we can call it as the heart of this Cody dryer, is the atomizer. Atomizer works on the principle of centrifugation, where the liquid feed, when once introduced to the atomizer, spins at a high speed, which generates a mist of the liquid particles, which gets introduced to the hot air that is supplied all over the drying chamber, and then it just interacts and there is a heat transfer among the heated air and the liquid particles, which converts the liquid particles to the powder form, which then moves to the other part. On the back of the Cody dryer is the heating element that heats the filter air and passes it to the atomizer, where it mixes with the liquid droplets, and then the atomizer just moves the air as well as the liquid particles inside the drying chamber, where the flow of the particle as well as the air is in the concurrent type of flow. So, in the concurrent type of flow, air as well as the particles move in the same direction. The main importance of the concurrent flow is that the heated particles in the liquid form are in the contact with the highest temperature, while the powder form is in the contact with the lowest temperature. Once the particles are formed in the drying chamber, they move towards the cyclone, where it gets separated from the air and it just passes towards the powder collector, while the residual air gets sucked off by the exhaust and it just gets out from the spray dryer. The control panel consists of different parameters that can be controlled in the Cody dryer. It consists of the exhaust fan, atomizer, feeding, heater, light and hammer. So, in order to start the whole thing, we just need to start the exhaust fan first, and then we start the heater so that it can reach the temperature that we need for the Cody dryer. The microcontroller has 2 different temperatures. One is the inlet air temperature and outlet air temperature. So, these values are based on the 2 sensors that are near the heater, and one of the sensor is near the exhaust system. So, in order to optimize the whole system and the drying process, we have to control these 2 temperature accordingly.